Now we are going to discuss about another important topic of this chapter, that is pressure. Try to push a nail to a wooden plank by its head. It's a little bit tough, isn't it? Okay, then try to push the nail by its pointed end. It seems quite easier. Why is it so? Why broad strap bats are more comfortable than narrow strap bats? Narrow straps hurt our hand much more if we carry weight than the other. Porters use a round piece of cloth on their heads when they carry heavy loads. Why? By this, they increase the area of contact of load with head. So, pressure is reduced. It is easier to cut vegetables using sharp pointed knife than blunt knife. In all these cases, the area over which the force is applied plays a key role in making tasks easier. There is some connection between force and the area upon which force is applied. The force acting on unit area of a surface is called pressure. Pressure equal to force by area on which it acts, that is P equal to F by A. Smaller the area, larger will be the pressure. Because P is inversely proportional to A, we can say that smaller the area, the larger will be the pressure. Pressure exerted by liquids. Do you know liquids also exert pressure? Let us check it with an experiment. Take a transparent glass tube. Take a rubber sheet and stretch it tightly over one end of the pipe. Tie it tightly. Hold the tube straight. Pour some water into the pipe. What can you see? The rubber sheet bulges out. Pour some more water. The rubber sheet bulges out more. From this we can say that liquids exert pressure on the bottom of the container and it depends on the height of the liquid column. That is, pressure is directly proportional to height of the liquid column. As the height of the liquid column increases, pressure also increases. Consider another experiment. Take a plastic bottle. Fix a glass tube near the bottom as in figure. There should not be any leak from the joint. Take care of that by sealing it with molten wax. Take a rubber sheet and fix it tightly on the other side of the glass tube. Pour water in the bottle up to half. What do you observe? The rubber sheet bulges out. Pour some more water and check. The bulge increases, isn't it? So we can see that the liquids also exert pressure on the walls of the container. And again, this depends on the height of the liquid column. That is why in the second picture, the water flows out to a large distance from a hole near the bottom of the glass. As the height of the hole from bottom increases, pressure decreases, or else we can say that as depth increases, pressure increases. In the third picture, we can see that a plastic bottle is taken. Holes are made near the bottom or around the bottle. The holes are at the same height from the bottom. The bottle is filled with water. The water is coming out of the holes and falls at the same distance from the bottle. What does this indicate? That is, liquids exert equal pressure at the same depth. So, what can you infer from all this? Pressure exerted on the sides of the container depends on the height of its column. A liquid exerts pressure on the walls of the container. Also, liquids exert equal pressure at the same depth. Pressure exerted by gases. You can see that gases also exert pressure. What happens when you prick an inflated balloon? The air inside the balloon oozes out with great speed, that is, the balloon bursts out. Similarly, what happens when a cycle tube punctures? The air hushes out, isn't it? Will you be able to inflate a balloon which has holes in it? No. So all this shows that gases also exert pressure on the walls of the container. Gases also exert pressure on the walls of their container. Atmospheric pressure. What is atmosphere? How much it extends? The envelope of air all around us is called atmosphere. It extends up to many kilometers above the Earth's surface. The layers of atmosphere can be named as troposphere, stratosphere, mesosphere, thermosphere, exosphere. The pressure exerted by the atmospheric air is called atmospheric pressure. How to calculate the atmospheric pressure? Weight of air in a column of height of atmosphere at area 100 square centimeter is as large as 1000 kilogram. Atmospheric pressure is the weight of air in a column of unit area. It is quite large. As the height of the atmosphere increases, the air particles there becomes thinner and thinner. So, as altitude increases, pressure decreases. We can easily understand how large the atmospheric pressure is by the action of rubber suckers. You might have seen different types of rubber suckers to hang different things on the wall. Do you notice where the sucker usually sticks well? Yes, it sticks strongly on smooth plain surface. When we press the sucker on the surface, the air between the cup and the surface is expelled or escaped out. In that case, the atmospheric pressure outside the sucker acts on it and keeps it attached to the surface. To pull the sucker off the surface, we have to apply a force which is large enough to overcome the atmospheric pressure. Do you get an idea of the magnitude of atmospheric pressure now? It is quite large. If we create vacuum in between the sucker and the surface to which it is fixed, then no one could ever pull the sucker off from it. The sucker sticks to the surface because atmospheric pressure acts on it, so to pull it we must apply a force greater than the atmospheric pressure.